also maximum power transfer, right? This one too, we use the OrCAD AD PSpice software to write the program. And then we use the OrCAD capture to draw the circuits, right? So supposingly, today we need to do Fourier series and two-port network. So you should already know how to draw the circuits, draw the components, something. Okay, where's the circuit? Something like this. Okay, then today we are going to continue our experiment for Fourier series. So first of all, you need to understand what is a Fourier series. So it is basically if your normally our input right, Vin you can see, right, Vin normally is maybe a 5 volt or 12 volt, right? So or maybe sine wave you have a sine 5t, then this is still okay. But the problem is if it is a sawtooth waveform like this, then for your input, okay, then how are you going to determine your output? Okay, so if your input this kind of sawtooth wave is your input, then we want to know what type of waveform at our output. And then normally if you use software, then you can visualize. You can use your eye. Your eye can visualize, okay, the shape of the something like this. The shape, yeah. So the black, yeah, is your input. The black line is your input, and then the green one is actually your output. So you can visualize. Okay, but what if you would like to do the calculations? So normally, if you want to do calculations or you want to have the equations, right, to represent this waveform, how are you going to do? It's not a normal sine wave. It's not a normal cos, sine, or tangent wave. Then how are you going to form the equations for this kind of waveform? This is a time that we need to use Fourier series. Okay, so actually, in short, Fourier series expansions is actually a method for us to represent the waveform in terms of equation. You want to change this waveform to its equation, then you use Fourier series. Can you understand it? So before we go in the how to do the use the software, then I have to go through review the Fourier series fundamentals knowledge. So basically, this is the final equations. Final equations for sawtooth waveform. Final equation for sawtooth waveform. Okay, this is a final equation. And how are we going to get these final equations? So it can be derived from this trigonometry Fourier series formula. So this is the formula for Fourier. This is a Fourier formula. So anything that we want to do, we want to derive the equations for not a common waveform like sine, cos, or tangent wave, then you need to use this Fourier series general equations to do the differentiation, okay, the integrations. Sorry. So what we actually need to determine will be the A0, AN, and BN. Okay, so A0, AN, and BN equations is given. So A0 will be integration 1/t integration from t0 to t plus 0, which is a period. So means it always repeat here. So the waveform always repeat from here to here, right? So yeah, maybe this is 0 second, this is 1 second, then you integrate from 0 to 1. Okay. Then FT will be the equations of this waveform. So this one maybe is a very simple sine wave, or here for this sawtooth waveform, it is from 0 to 1, right? It is just a straight line equation. Okay. So that you can use y equals to, you can use just a straight line equation. Then you can use y equals to mx plus c to get the equation for your ft. So this ft. Are you okay? Today, I found out today you can see my PDF file can. Microsoft Word cannot. Okay. Okay, that's good. So N naught, okay, already AN and BN just a formula 2 over T FT cos and then BN 2 over T integration FT sine. So from these equations, after you get A naught, AN and BN, then you need to substitute back here A naught, AN and BN. Are you okay? After you substitute back here A naught, AN and BN, then supposingly you are going to get this final equation. Any questions? I think you learned a Fourier series in your mathematics class, right? Are you okay? Can you understand how do we do the derivations then to get this final sawtooth waveform? So basically it will be the general Fourier series equations. Then they have three unknowns, N0, AN, and BN. From this N0, AN, and BN, then they have its own formula. So from this N0 formula, AN formula, BN formula, then you do the integrations. Then basically you will get you will get it and then substitute here. Then you combine them, then you get this. Okay. You learned before, right? Oh, you learned this morning, ah? Oh, that's good. So then I can just give it. Okay. Anyhow, I won't go through the details for these chapters. Yeah, this is I think chapter 8. So but the recorded video already there, so you can watch a recorded video. I think the recorded video also very brief. Okay, so you can watch a recorded video for this chapter. And then also the lecture notes. Okay, the lecture notes have some examples of how I do the derive. I mean they are forming the equations and then integration of this and BN and BN and not. Okay. So last time this chapter is in your final exam. So that's why we discuss very details of tutorial and lecture notes for this. But then after that, I remove this because if this is included, then the whole paper is very, very tough. That time the passing rate is only, I can't remember, but then it's actually have very high failing rate. Okay, I think maybe 40 to 50%, half of the students will fail. Then after that, I remove this tutorial series from the final exam, and then I put it in the assignment, so it's in your lab assignment. Okay. So Remy 5 stars. Okay. So this is in your lab assignment. That's why, but your tutorial and the lecture notes, I won't really go in for this chapter. Okay, but as I said, this is assignment. My assignment means you have to do your own work, and then I already record it, and also have the lecture notes about this topic, so you can always read it and complete your assignment. Okay, so it's not in your. You can look at the recent years past year questions. Actually, it's not in already. Okay, but it is in very I mean maybe the beginning of my years in Da UC, Da College at that time. So it's like very tough, very tough that time. The exam question is very tough. Then after that I remove. Then they can spend a day. The students can use two pages, okay, to write the integrations for this Fourier series. 2 pages, and not yet include others 2.9 Laplace. And last time the knot of mesh analysis also very tough. So after that I remove this. And I mean I reduce the standard a bit. I mean to be more appropriate to the standards of the students. Okay, so so then but then it doesn't mean that you don't need to study. So you have to study for your lab. Okay, so okay, this is okay already, right? So from this, then you get this final sawtooth waveform. equations. So what I want to tell you is, now you have another equation. This equation 4.6, is the equation for P spy. So P spy will represent the P spy will represent the trigonometric Fourier series using sine rather than cosine. So you don't ask me why P spy this equation. This is internally fixed by P spy. So means after you run P spy, then basically you get this table. This table. This is from results from P spy. Then from these results, you have to substitute inside this predefined P spy equation. So you have to substitute inside here. From the result, after you run it, you build the circuits, you run it, and then you get the result table like just now. Then this table, that table results, you have to substitute into this equation. So means this result, this table, figure 4.7 and 4.8, these results, you substitute into one for input, one for output. You substitute into that just now the P spy's equation. Okay, then you are going to form this equation. So this is one, I think this is for input, and then this will be for output. This table for output equations. Is that clear? But this is actually not yet complete. So you have this one we run for 10 harmonics. So suppose I have plus dot 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 here. Plus dot dot dot. Okay. So can you understand? So I would like to tell you what is the difference only. Okay. This is actually from theoretical calculation. You understand what is the meaning of theoretical, right? So by using the formulas, theoretical calculations, you get this equation. And these equations is the P spice equations for Fourier series. Okay. Anyone have any questions? If you are okay, then we look at the examples questions here. So they say examples so they use a sawtooth waveform as an input. Okay, so this sawtooth waveform as an input to perform the transient Fourier analysis, okay, on the circuits and determine the Fourier series expansion for both input and output waveform. So they would like to know the Fourier series equations for both input and output waveform. So this will be your input, and then your output will be here across the 100 microfarad farad capacitor. Okay, so how are you going to do? First, P spice, you need to draw something like this. Okay, then how are you going to, put in the waveform? So you need to use a component called a V pulse. Okay, component called V pulse. Then you need then they have a series of parameters that you need to set: V1, V2, TD, TR, TF, PW, and PR. And what does it mean? So basically, here already explained. So V1 is the initial value. So you start from here. Then this initial value will be V1. V2 will be your pulse value, means your final value. Then TD will be delay. So you delay for how long? Then only it's rise. Then rise time, so means here to here, it rise for how long? Rise it for how long? Then fall time, TF will be fall time. You fall for how long? Fall time here. Then PW will be the pulse width. Pulse width will be this, right? The horizontal line. Pulse width. And then PER will be the period. So means that you are going to repeat the same pattern here. Okay. One pattern will be will takes how long? Okay. Can you understand this? So that's why, in order to have our sawtooth waveform like this, that means you can see that your V1 equals to 0, V2 equals to 1. So correct along the 0 here, and then 1 here, 1 here. Then TD delay time equals to 0 because it didn't delay, it's straight away start. Okay, rise time, so it rise for 1 second, right? So then fall time is straight away 4. Okay, so equals to 0. So PW is equal to, because you don't have the horizontal line. And then period PR equals to 1 as it repeats every 1 second. Can you understand this? So this is how we get this. Okay, I think other than that, it will be the same thing that you learned before. So if you don't have any questions, then please start to draw these circuits. After you done drawing the circles, then you need to set this. Okay, set the what you call it, yeah, simulation settings, right? Then you have to set this, and then you need to click this output file options. Then you need to pick this perform Fourier series, then 1 hertz, and then number of harmonics 10, because it's actually up to you lah, but we put 10. Then output variables will be CV1, comma, space VV1. So means we want to print the C1 output graph, and then as well as V in. Okay, so this V in is up to you. But I put V in because I already renamed my input file as V in. For some, if you didn't rename, then it will be V1. If V1, then means here you need to type V1 instead of V in. Okay, this is one thing. Another thing that have a lot of the prompt mistake is the prompt error is here. You have to put a comma, then a space. Okay, after a comma without a space, later you run it, you are going to have error. Anyone can't get this? If you can get it, please type 1. Okay, please, after a comma, then you put a space. Without a space, later you will tell me, means I have error. Then it is normally it's because of this. And this kind of thing, actually, last time I spent some time to find out. Okay, so now should be no problem already. Okay, yeah, I only have 3 students. Others, are you having your lunch? Haven't come back yet? Yes, like what Kibun say is right. Okay, so if you are okay, then okay, so it's your time to start the P-Spy. So it's P-Spy AD, sorry, P-Spy all-cat capture. All-cat capture, yeah, here. So you can run the program and then right, like last round. So run the project, open the new project, and then save it and save in the folder, right? Then okay, can you do it now? If you forgot already how to do it, then you can refer to the previous lab. Okay, lab 3. This one. Okay, creating a project. Okay, then you name a new project. You can name a Fourier series. Then you find a location to save it. Then create the library. We will create from this MDAA all libs. Then place a component. Okay, do it now. So it will be very fast. Only 3 components. This one. Okay. And meanwhile, I will open the file that I already draw it. Any question? So how are you? How are you doing? Anyone have any problem? Yeah, I did the wrong thing. Eh, I did do okay. Computer a bit slow. Where is the output file option? Output file option is from this. After you draw it, right, then you need to go to this create a new simulation profile. Which voltage source using voltage source, then you need to here you type V pulse, V pulse, V pulse. This one. Eh, oh, here. Okay. Then you need to key in the V1, V2, TT, TR the parameters. So these parameters later you can try. You key in the other numbers, other values, and then they will come out other thing. Okay. Okay. Uh, okay. Then where is the output file? Where is the output file? So after you draw the thing, then you need to go to new simulation profile. So I already do it. So I go to edit simulation profile. Then this one output file options, analysis, time domain. Why it looks a bit big? Can get that heading. Then this one output file option. Then you need to tick off perform piece file. And this one mine is V in. So that's why you need to look at yours. Is V in or V in? Your V in or V1. After you're done, then you can run it. So if you are V in, then is it you are V1? Did you? Okay. I think I also will have. Okay, do I have error? I mean, view of okay. If you run it correctly, then eh, yeah, then you will have empty blank graph like this. Then you go to view output file. Then you scroll down. Then basically you are going to have this table. Okay. So if you have error like edit, so you need to check. I accidentally delete this one. I name is as V in. You name as V1, is it? If you name it as V1, then just now in the piece file setting there, then you need to set that. Yeah. Then my mind is V in. How can I want to display the a the ID parts reference begin. edit display. Display name only, value only. Okay. Okay, so yes. Nah, my in come already. Just now maybe I accidentally delete this. Understand? Yeah, if your normally by default is V1. So a lot of students forgot to change this one to V in. Then follow mine. Mine is V in, right? Follow my setting here, V in. So if you don't want to change to V in, it's okay. Then here you write V1. No? If you here you write V1, then should be no problem. Okay, can already. Anyone else have problem? Put the value or the V in. Put the value. No, actually this one should be automatically come out. Just that I accidentally delete it. Understand what I mean? Where you put the new components, right? You can see V in already here. John, can you see V in already here? Yeah, so you no need to delete it. I go to delete because I accidentally delete it. Then I want to at the side, what at the side? The V1 and V2 at the side. 0101. I can't understand what 010101. Oh, yes. This one, yes. Or how to edit this value, is it? I think you just double click, then value here, right? Type 0. Okay, come on already. Oh, you are okay. Oh, now I know what you want to ask. This one is it or whatever? Double click it, then change the value to 1. Click OK. Okay. And Kaitong, you have error. What error is that? This one supposedly is. Do you have a space? Do you put a space? Supposedly it's a space problem. Space V in. And other than that, will be you check again. So is it because of something? I mean, like the one, then you type I, or this V, you type I. Supposedly, this kind of error problem should be from here. Maybe the I, then V in, then you write that V or something wrong somewhere. Okay. Should be from here. You try and got it already. Oh, you settled? Python okay already. Others? Anyone else have problem? Error? Um, if like that, I have to check your diagram now. Then I will stop sharing. Then Kaitong, you need to share your screen. For those who haven't done, then you please continue your work. For those who are already done, then you rest a while. After your friend's done, then only I will explain further. Okay. So now I check Hai Kaitong's work V1. What is the 1B beside your R1? 18, yes, you can go makan first. You also don't know Why suddenly you have the 1B And your resistor also a bit weird. Do you change you what I did You are I can't see sorry. Uh, I always feel my screen is a bit no. You put R analog resistor. Don't type resistor, you just type just type R. Just type R. Yes, first one. Don't run first. Yeah, I want to see your simulation profile. Run and see. It should be got error meh? I think okay already, right? Still the same meh? I didn't see got any error. Your capacitor also have to change it. Change it to C analog. And then your ground, I'm not sure whether you can straight. I can't remember already. I feel like I got some problem. Is it not cannot straight away attach? Maybe you need to put a wire. It looks better now. Uh, yours is never mind, you try again. Can can I look at your warning there? Your design does not contain a group. So your ground should be the ground with zero, yeah? You are selecting the wrong ground. Yeah, I think this one okay. Actually, I also have the same problem like you. I don't know why every time we need to put in the last time it's not like this. I mean the piece right. You press run all gone. I don't know why. What do you mean by all gone? 1 minute I solve one by one. So 开动 okay already Okay, so Kaitong, okay. So yeah, that's right. Others, who is the one who say oh gone? Ren Jian, okay. John, okay, right? So output file option is from the, where is it? PSpy new simulation profile, yeah. So Renjin, what is your problem? PSpy new simulation profile. Okay, I should go to edit. Edit simulation profile. I already created, so I go to edit simulation profile. This is an output file option. Yeah, then you can follow the settings here. Renjian, your cannot means what? Can you share your screen, Renjian? Renjian. Okay. What do you mean by all quant?
Like this one, I don't know why.
This is correct. This is correct. If you pop up the empty graph like this is considered correct.
Huh?
You still remember you want to have the plots, then you need to go to trace, add trace. Then you go to, if confirm you are okay or not, then you go to view on the top there, menu there, view, output file. Output file, the first four. Yes. Scroll down, scroll down, scroll down, scroll down, scroll down. Yes, you are okay. This is the result. Then okay. If this means most of you okay already. Anyone else cannot? If nobody cannot, or something got problem, why mine won't pull out the simulation setting after I click new simulation profile? Wow, this one I really don't know. Maybe you share your screen. Are you using the? Supposing you use OK Capture only, you can draw the circles, right? Then restart your software. Yes, restart your software is a good idea. You save it first, then you restart the software. Other than that, that is one problem. That is one possibility. When you create your new projects, right? Sometimes you forgot to when you create a new project here. When you create a new project, did you choose this analog or mixed AD? If you didn't choose analog or mixed AD, oh, yeah, well, I can see. Okay, I share now. My screen, this one. I mean, when you create your new projects, right, in Lab2, right, creating a project, then they will ask you to select this one, right? Create a project using analog or mixed AD. So Song Jian is the one who have problem, right? Did you choose this analog or mixed AD? Because if you choose PCB or schematics, right, then later on or others are PLC, programmable logic wizard. That means that the simulation button actually won't really there. Okay. So got that means you save your work, then you close it and open again and see. Or maybe you have to wait some time. Sometimes the computer slow, then the simulation setting after you click also have to wait for a few seconds maybe. Other than Sonjian, others. If you're already done, then can you respond? Maybe type done. So the done means supposedly you are going to have empty graph like this. Then when you go to view output file, then this one will pop out. Then you scroll down, you have this table. That means this one means done. So and this empty graph, like just now Renjian thought is something wrong. Actually, it's not. you want the graph, then you need to go to trace at trace. Okay, for example, we want C1 pin 2, then C1 pin 2 come up. Then we want the at trace, we want the input waveform, right? We want to know whether the input waveform is a sawtooth waveform or not. V1 plus. Yeah, can you see? Maybe I change the background color. Tools options. Color setting. My computer also a bit slow. Not responding. So then, after restart, can solve the problem or not? Color settings. Yeah, go to already. Yeah. Okay. Change to white color. Can you see the sawtooth waveform? This the sawtooth waveform, the red color will be the input waveform. That means the parameters that we key in just now is okay. Means it is a sawtooth waveform. And here I want to make it thicker so that you can view it. Okay, so the green one is actually the output waveform, means the output across the capacitor. And then okay, so if you change your values here, then you are going to get a different rate plots, the input waveform. Okay, so then about the equations, so supposing you are in this, this will be your results. Okay, so one for this is for output, I think. Yeah, this we in for input. Okay, so this is for input table and this is for output table. So why it has 1 to 10? 1 to 10 is just now you fix it. So you say you want to have 10 harmonics. So then they have 1 to 10. So this is frequency, this is Fourier component, normalized component, no need to care about, and then the phase. So what you need to do is this table, then we want to put inside this this Fourier equation. So this C0 is basically this one. DC component here. This value. Okay. So you have e power 0 negative 0.1 means times 10 to the power negative 1. So 4.99 times 10 to the power negative 1, so means 0.5. 0.5, right? Roughly 0.5. So that's why we have roughly, I'm looking at the output, so 0.5 here, 0.499. Okay. Then the next component is what? Cn. So Cn is actually your this Fourier component. So 2.696 times 10 to the power negative 1 means 0.2696. Okay. Normally, so we don't need to care. Then phase angle. So phase angle is basically your this theta. Are you okay? So n omega t is actually omega t means is actually your 2 pi fn. Okay, so your frequency omega, right? 2 pi fn t. So that's why they have the value of this. Perhaps we look at the input graph. So 0.4.95 times 10 to the power negative 1, right? You get it. So you get 0.495. Oh. Then for the component here, 0.3184 here. So 10 to the power negative 1, so it's 0.3184. Sine 2 pi t minus 178. 10 to the power negative 2, so means 178 degree. Understand? Then this is the equation is summations, right? So summation, this is for n equals to 1. First one, then second one, third one, like that. Can you understand? Can you understand? If you can understand, type 1. If you can't understand, you type 2. Or you are still doing. Can you respond a bit? What are you doing now? You are still trying the. Can you get this graph? Brian, can I know trying for what? Is the graph, is it? A slightly different a bit is still okay lah, but supposingly should be the same value. Or so John is checking what's wrong. Maybe because of the values 1K and 100 micro. Did you change the value here? How to see the graph again? See the graph actually the very fast way is you use this one. Voltage level meter. You click here and you click here. And later on when you run it, it will automatically pop up. Yes, you automatically pop up the graph. If not, then just now I go to trace here, then add trace. So add trace for where? One will be V in, one will be C1, then pin, this is pin 2, yeah, pin number 2. Can you all see? Pin number 2. Then this is pin number 1. Okay. You change the values already. Yeah. How's very, very slightly different, then should be no problem. 100 micron. Is it 100 micron? Yeah, 100 micron. Others? Brian? Okay already. Yeah. Done. Okay. Can understand, right? So means you okay then so how you know that whether it match with your theoretical calculation? After you got the results from this, right? Then you form these equations, right? So after you form these equations, then you should be able to compare with the equation here from your derivation, theoretical derivations, the Fourier general equations, integrations. Then you have these final equations, right? This is theoretical equations. So you can substitute value here, expand here, then you compare this one with this equation. That means you will verify whether simulation and theoretical results are matched or not. Can understand? If you can understand, please type 1. Then I will close case and go to the next experiment. If you think you need more time, then you let me know. Understand? Good. Why sign? Why sign? Why not? This one is from P-Spy. Just now I got mentioned, right? This is from P-Spy, represent it using sign rather than cos. I also don't know why. I think they just fix it. So it's like when I fix sign, then you ask me why sign. When I fix cos, then you ask me why cos. Actually, no reason. I think they just fix it so that there's a rule. So can you understand? It's actually they just fix it. So you ask me, so I can't really tell you. Like why you ask me why the Fourier integration need to have integration cost for AN. These kind of questions you have to ask a mathematician. Understand? So piece five I check, and then they say actually they fix it sign. I haven't released the assignment. Later I will release the assignment. Oh, you want to have a break 10 minutes? 10 minutes can, no problem. Okay, we have only okay. This experiment roughly you can understand, right? Okay, then okay. If you're done, then we break for 10 minutes. Then we will go into the next last experiment. After the last experiment, then we end the lab. Supposingly, we will end before 4 p.m. Okay. So any questions? If you have questions, then you stay and then we will solve your problems. If no questions, then you go for a 10 minutes break. Maybe be back at 3:15. Okay. So anyone have any problem, then you can ask now. I mean the problem for this Fourier series lab. Meanwhile, I will post your assignment to Google Classroom now. Song Jian maybe you share a screen and let me have a look. There must be a reason. This problem is, I think it's first time I hear it. There must be a problem. I already posted the assignments in classroom, yeah? Lab assignment. What is the error? Yeah, is it because of different name? Why you want to set that name?
Yeah, I tried different name because I said before that name.
If you already said before that name, right? What do you mean by you said before that name? You are
Just now I
having
tried to set with the name for real, and then the setting won't come up. So I
but
try
what is your
again.
no, what is your project name?
For real series.
Then you type Fourier series and see.
Okay.
I'm not sure about, but normally we were having the same simulation profile name as the project name. What is this error? I can't see. Can you read? I can't see. What is that?
I said, Fourier series is invalid. The simulation name.
Fourier series is invalid.
Yeah.
Oh yeah. Then like what Edin said, you need to put underscore. Don't use space.
Okay.
Cannot space. Oh, wow, you're very professional. Very good. I actually never realized about this because normally no problem.
Still
Experience.
nothing.
Good. Okay. You try and see.
Try
Put an
to.
underscore.
I put already.
Put already Can already
Then nothing happened also.
Nothing happened also
Yeah.
Go in again, please, right?
Edit on.
Then you go to new simulation profile.
And
Then you type again just now. Fourier series create. Seriously, I have no idea. Why like that?
don't know. Maybe need to reinstall.
You try already min close and open back, is it?
Yeah.
Why you have? Can I see I can see that you have other thing below. I mean, we open the P5 AD, is it? Software.
This one is.
The next one next week. This one.
This one is.
Nothing one, is it?
Nothing one. Yeah. I haven't opened one. The
Haven't opened,
size. Yeah.
Try edit. He tried to click edit already, but nothing out. Why? Faster help your friend. How come? I will suggest you to. I will suggest you to perhaps. You close it first. Close it first.
Yeah.
There must be something wrong somewhere. You close it first. Then do you still keep the file that day the Lab2?
No, because that day also my software not responding.
Sorry.
The day my software not responding, so I didn't keep the file.
Oh, so you didn't do that.
Yeah.
Oh, actually, I asked you to close it because I want you to try that one. Okay, try to run that one.
Yeah.
Then, do you think you have problems in doing your assignment?
Or maybe I try to install another version for this one.
Yeah. I feel like a bit unstable. Yeah. Then perhaps you will have. If you have problem in doing your assignment, then you need to let me know. I will find a way.
Okay.
I will send the laptop to you.
No, never mind lah.
See your friend so humble. Hey, Ziyan raise a hand. No, I know you want. Then I won't say. No lah. I know that Songjian will say no need, so that's why I say so. Okay, but anyhow, please let me know if you have problem in solving your. I mean, yeah, in this kind of software. Then perhaps yeah, we will find a way to help you. Okay. So try and install another, yeah, reinstall the software, and then I mean, because this kind of thing actually not really, yeah, not really happened before. So I don't think it's a software problem or your problem. I think should be something wrong somewhere that you may reinstall the software or try another, the lower version, right? I think 16.8 and see. Okay, if you can't, then you let me know. Okay, then it's time's up already, right? Okay, I already posted your assignments in classroom, but I will go through with you later. Okay, before we go to the next lab, then you can actually I haven't shared my screen. And screen 2. Okay. So you can actually, after you save it, then actually you can close this Fourier. Yeah, you can save all. I don't want to save, so I click no all. Okay, then next one will be two-port network. So two-port networks videos actually already in your, yeah, Google Classroom as well. But two-port network I will go through with you in lecture class because it is, yeah, it is 25 marks questions in your final exam. Okay, so this one we will discuss in detail. But then in order for you to complete your assignment, then you have to watch the recorded video, do your own study first because this is the last chapter. So normally we will do it around maybe week 11 like that. Okay, so it's after your lab submission. But now I will brief you what is 2.11. So I will brief you that you are able to understand and do your lab assignment. Okay, but the details you can watch the recorded video. Yeah, but actually it's not that difficult. Okay, so are you ready? So I think this is first time you heard about two-port network, right? So normally we deal with this kind of network, one port network. That means that we have a current in, then current out. Then maybe it's a resistor. Means resistive network lah. Then they have a lot of resistor, maybe series barrier, so going out, something like this. Then when we deal with this one, we call figure B, we call two port network. So we have this one, we have port 1. Here we call port 1. Here, then this side we call it port 2. Okay, and the plus minus V1 and current I1 going in, plus minus V2 here, I2 going in, fixed already. So you don't simply change the directions, let it go, come out here. So it's fixed already. Okay, then just follow here. So two-port network actually, the theory actually is very simple. They have a few parameters. We have this one we call hash parameters. Okay, then we also have Z parameters, Y parameters, T parameters, A, B, C, D parameters, and so on. But all of them actually are nothing. Okay? They just have its own rules and formula. So what is the meaning of H parameter? It means that you need to determine these four: H11, H21, H12, and H22. After you get the values of these four parameters, that means H parameters, that means you already solved the questions. Understand? So what is the value for H11, values for H21, values for H12, and values for H22? After you get the values, then means it's solved. But of course, there has its own conditions that you have to follow. So let me separate into two. Okay, so H11 and H21, it is the formula is V1 over I1 and then I2 over I1. And don't tell me how you get this formula. This formula already fixed, derived by the mathematicians. And I don't like to know how we do the derivation because we are engineers, not scientists, not mathematicians. So I normally will just teach students how to apply the formula. I think you like it, right? So then, yeah, so H11 equals to V1 over I1, H21 equals to I2 over I1. Okay, then there is a condition. You have to find this when V2 equals to 0. So what is the meaning of V2 equals to 0? V2 will be at your port 2. So V2 equals to 0, it means port 2. Anyone? V2 equals to 0 means port 2. Open circuit, short circuit, right? Short or open? It should be shorts, right? So it means that your port 2 here, you need to short. So the circuit is like this. That means that you have to short here, port 2. Okay, so in order to find H11 and H21. Okay, that's why I short here. In order to find H11 and H21. Okay, so what is the answer? See, you calculate H11, you get 10 ohm, and then H21, you get negative 0.5. Yeah, negative 0.5 without unit. So this will be settled for H11 and H21. So this is our answer. This is what you need to find. Okay, so done it is. Then the other two will be H12 equals to V1 over V2, H22 equals to I2 over V2. So formulas is like this, fixed already. Don't ask me why you get the formula. I really didn't study how to get the formula. Okay, so then conditions, I1 equals to 0. I1 equals to 0 means your port 1, you need to get port 1 current equals to 0. Current equals to 0 means your ports 1 need to open. Understand? So that's why your port 1 here have to open. So far, can you understand what I mean? Can Okay, so it's basically they will give you a circuits. So two-port network circuits is roughly like this. So you have two sides. This side will be port 1 and then this side will be port 2. Okay, then formulas given. Okay, in the lecture notes you have formulas for H parameters. You have formulas for these Z parameters, Y parameters, T parameter, ABCD parameter. All the formulas already in the lecture notes. Okay, so last time you had to memorize the formula in order to sit for the final exam, but now online assessment, so you don't need to memorize the formula. You can refer to your notes. Okay, then the formula is roughly like this, just that they may change. Maybe like Z parameter, Z11, then maybe a V1 over I2. Then Z21, maybe like I can't remember the formula. Maybe V2 over V1, something like this. They only change here, but roughly like this. V1 over I1 or V2 over I1, yeah, VI, those things. Okay. Then they will have conditions. So for example, H11 and H21, they will have condition V2 equals to 0. Then H12 and H22, they will have condition port 1 open. So different parameters will have different formulas and different conditions. Sometimes port 1 open, sometimes port 1 closed, sometimes port 2 closed. So you just need to know what is their conditions and formulas only. Okay, but the way of doing is the same for all. Can you understand? So we don't talk about other parameters. We talk about H parameters here. So H parameters here, the conditions is H11, H21, your port 2 need to short. and H12 and H2, your port 1 need to open. Then by using these circuits, they want you to find the hash parameters for these circuits. So you need to follow the conditions. You need to have 2 circuits. So one circuit we do port 2 short, another circuit we do port 1 open. So that's why you need to draw 2 circuits. This is finding H11 and H21. We short our port 2. Then if you short your port 2, then you can put a current source or voltage source. You can put a source at your input side, port 1. Okay. Then another circuit, we open our port 1. That means your output port here, port 2 here, you can put a source. Okay. And why they put a for H11 and H21 circuits 1, they put a current source. Why they put a current source? I1 here. I1 because I1 is here. So they put a current source and they make the current source 1 amp. They put a current source and they make the current source 1 amp because in your PSPI, you only run it and then get one answer. You can only get V1 and I2. You cannot get, they won't help you to calculate V1 divided by I1, I2 divided by I1. Can you get what I mean? So your circuits, okay, my answers are so that we put in 1 amp here for your I1 input current I1. Do you get what I mean? This one. I1 here. We put in I1 here 1 amp. Why we put in 1 amp? Because if you put in 1 amp, what does it mean? You run this is 1, right? Divided by 1, that means whatever you get for V1 will be your H11. Whatever value that you get for I2 will be your H21. Can you understand what I mean? So for this port 1 open, then they will put V2 equals to 1. Okay, because whatever value that you run and you get for V1, then will be H12. Whatever value that you run, you get I2, then will be H22. So if you ask me, Miss, I don't want to put 1 amp or 1 volt, can I? Can. You can put 2 volt, 3 volt, 5 volt, up to you. Yes, it's to make your life easy only, okay? Because you have to understand this is what? This is ratio. H11, for example, if you get, example only, if you get 2 volt, then over 1, you get 2. Okay, so if you want to you want to put 2, that means your answer, you will get 4 for your V1. Understand? And eventually you divide it, you are going to get 2 as well. So you say you don't want, you want to make 4. So you put 4 here. That means you should be able to get 8 volt for V1. 8 divided by 4, you will get back 2 for H11 as well. So this value actually is not very important, just to make your life easy only. So you put 1 amp. That means you can run later this is simulation then you can run later and you put 1 amp, then you run 2 amp and see what is the result. Supposing it should be double of what you get when you put 1 amp. Understand? Okay, so I want to explain this because I worry you can't understand why this one suddenly have one current source here. Just now the circuits, the original circuits is actually without any source, right? Why we put the 1 amp here, then suddenly we put another circuit, we put 1 volt here. So it is because of this, okay? Other than your port 2 short, that means your port 1 you can put a source. Your port 1 open, that means your port 2 can put a source. And what type of source to put is actually up to you. And in our theoretical calculations, if you watch the recorded video for 2-port network, and later on when we discuss the tutorial questions, everything, you will find out, actually we didn't put the source at all. When we solve for theoretical calculation, we actually didn't put the source. We will play around the formulas, find the ratios and then play around move around the formula so that it is in this form. And then suddenly, maybe V1 and V1, V2 and V2 can cancel out and then left in this format, V1 over V2. Then we get the answer. Something like that. But it's not important. Which way to settle the question is not important because you eventually you're getting the same answer. Okay, so this one okay already. Then theoretical wise okay already. Then how to do the simulation? Simulation wise actually nothing. You just draw like this. But one small problem is you have a dependent source here. Can I know what is the name of this dependent source? Xiu Qing, what is the name of this dependent source? CCSV. Yes, current control. Who is Xiaoqing? Xiaoqing, are you here? Yeah, current control voltage source. So for current control voltage source, they actually have placing the dependent source. Yeah, placing the dependent source. This one I already answer why we need to put one and one source. Okay, actually you have to refer to, there's a symbol. Like last time we said V must be for voltage, right? Must use for voltage. I must use for current. Then the dependent source actually also has its own symbol. Here, dependent source is under, I think, Lab2, I think, but this is not important, okay? So what is important is the letter E. Voltage control voltage source, the name must start with E. Then for voltage control current source, the voltage, the letter must start from G. Then for current control current source must start from F, and then current control voltage source must start from H. Understand? So like what Renjian and Edin say is CCVS, current control voltage source. So we have to use H. Can you understand what I mean? So that means when you key in here, I think when you key in here, this one, EHGF, okay? So it means for which dependent source. So for example, that's why we use H here. It is because current control voltage source is actually H. And you actually no need to do anything when you key in the, I off it already. Never mind, later I will show you how to do. Okay, you just need to key in, like just now, resistor you key in R, voltage you key in V. So you just need to key in H, then you will have that component out. Okay, then analog library. Yeah, the gain, then you need to edit the gain. Yeah. So for example, the gain here is 4ix, so we need to edit here 4. Okay, then how to put it in? So it's actually very easy. Okay, you need to look at this one. So gain equals to 4. You change here. Then this is current. Yeah, it's very easy to see from the symbol. This is current and this is voltage, right? And you can see, right? This is current, this is voltage. And the current actually link from where to where. So you check back your circuits. Current Ix, current actually links from 10 ohms here, okay, to ground. Understand? So you put your currents here, link to this 10 ohm. This 10 ohm is between 5, 6, branch out 10 ohms, right? Then your connections will put like this. And then I don't want to tell you anything. Okay, that's the question that I want to ask you in your lab. Okay, then okay, how about your voltage control? Voltage part plus is to 6 ohm, negative is to 10 ohms. So you connect accordingly only. Okay, then plus you connect to 6 ohm, the negative you connect to 10 ohm. So this is how we connect for this one, dependent source. Other than that, I think nothing much already. Yeah, again, then okay, now you can start draw the circuits. I will show you the final circuits I draw. Okay, it's again OCAD capture. 18, the file that you done just now, can you send to Song Jian? Song Jian, perhaps you get the files from your friend, maybe 18. Then you open again and see if you can like edit, like just now the edit simulation program. If not, then you let me know again. If can't, then I will try a way to help you. Can you all understand about this lab experiment 5? So basically, yeah, basically you need to draw 2 circles, and you can draw the 2 circles in one file. I will show you my answer. No, if you send the circuits to him, you need to send the dot OPJ file. .opj file should be this file. This is a project file. You reinstall it. I thought you want to install the lower version 16.3 version. Yeah, try and see. But no, never mind, you don't do the installation first. You are now okay. But I mean, just now when I explained, you listen first. But no worry, I think it's recorded. Okay. So basically, you need to, you all can see, you need to draw this out, and yeah, I remove the values first. Okay, yeah, you can draw two circuits side by side. One is to find H11 and H21. I short my port 2. Another is to find H12 and H22. I open my port 1. Okay, and then this one is I1 equals to 1M. This one supposedly is V2 so should be port. This is actually a port 2. This one should name to V2. Okay. Okay, I give you all 10 minutes to draw the circuits, then only I will explain a bit more. So you need to understand that this is the symbols in PSPI, and the lab manual or the action notes here. Yeah, this is the equations. So means when I say V2 divided by V2, so you cannot say, why this is V1? Of course, this is V1. This is a name from PSPI, so you have to rename it to V2. You should know that this is actually port 2 side. So actually, this is V2. Okay. So how we know that which one is port 1 side or port 2 side? Yeah, look at the circuit. Okay. So port 1 side is here. So it's 5 ohm here. Yeah, 5 ohm here. So this is port 1 side. So why I short 10 ohm here? Because 10 ohms here is actually your port 2. I need to short port 2. Okay. So same thing go to your this one, the other circuit. So you need to open port 1. So that's why here open. Supposingly you have this one 5 ohm. Okay, but I open already, so straight away start from 10 ohm. Okay. So I hope you can understand. Anyone have any problem or questions want to ask? So you need to draw this. Okay, I give you 10 minutes. You do it first. The current source is normal DC current source. It's not a normal current. This is normal current DC source. This one, then you if the dependence source, right? You just need to type here H, then they will come out this. Okay, so supposing it's in the source library. Okay, so like I type F, and no, like actually my library here actually got problems already. So it's you can't refer to mine. Okay. But what I want to tell you is you don't need to do anything. You want this dependent source, right? You just need to type H here. Okay. So for this one, yes, just to type I, then IDC. Then this one will be VDC. Okay. So try it now. I'm waiting for you. If you already done, then you type 1. Or some of you already done. Most of you already done. Maybe we wait for 5 more minutes. Others, do you have any problems other than Song Qian? For those who didn't reply, may I know what are you doing? Kim John 凯东民航人间小渊子渊和重建过的 again. So Qian doing the installation. Okay. So means most of you done already. Anyone haven't done? You okay, right? Okay, then how are you going to know the result? So this one, the graph is not important. So when you do the settings, we go to P5, new simulation profile, right? I go to edit simulation profile. Then wait for 1 second, 2 second, 3 second, 4 second, 5 second. Eh, why you didn't go? Eh, 1 minute, a bit weird. Eh. Refer to the lab manual. Okay, you just need to do the. It's a bit hang. Crash. What's that? No. Eh, how I didn't show you how to do the setting. Here, enable run P5 by select the bias point analysis. So what I mean is actually P5 here. Yeah, finally it come out. So you just select here. Instead of time domain or DC strips, we select this bias point analysis. So then you just like that, then you click OK. Okay. Then what when you run it, okay, then you just click here, V, so we can display all the voltage. So we are interested at voltage at V2. So it means voltage V2 will be here. So it means it is 2 volt. So that means your substitute into these equations, it will be V1, V1, right? We are interested in V1 over I1. So V1 here is actually 10 watt. Can you see? Can you see? So it is 10 watt over 1. So that's why we get 10 over 1. 10 over 1. So we get H11 equals to H11 here. H11 equals to 10 ohm. Can you see? Can you get what I mean? Then H21. H21, the equation is I2 over I1. So you need to get the current. So you select this one, select current. So current I2 I1 is 1 ohm. So I2 is here negative 500 milliamp. So negative 500 milliamp will be your I2. So that's why we have negative 500 divided by negative 500 milliamp divided by 1, so we get negative 0.5. Can you get it? So this is how we get it. So same thing go to your this one circuit 2 to find H12 and H22, and then substitute the relevant values into your equations. Okay, and I think yours will be very messy. You can actually drag it, okay, and then arrange it nicely. Okay, then you can have both voltage and current, but normally we view one by one, then it's meter. Okay. Any questions? So as I said, once you get H11 and H21, then this one H212 0.833 and H22 0.1833. That means you already solved the questions that they want hash parameters. Can you get what I mean? And about the theoretical calculation, perhaps you would like to ask me, then how about the theoretical calculation? So theoretical calculation is nothing. Theoretical calculation is just a normal circuits that, like just now, okay? When you short your port 2, then normal circuits, then you do anything that you learned before, the what mesh analysis, log analysis, what you call all the circuit analysis method like Ohm's law or superposition or maybe source transformation. So all the method that you learned before, you'll find V1 over I1. Maybe like current divider, voltage dividers rule. Can you get what I mean? Any question? Anything that you would like to ask? I can let all of you get this answer. I think should be no problem, right? If you draw the circuit, anyone have any problem that you run then can't have the answer? Okay, no problem. Okay, if no problem, then actually our lab is just like that. Then I will brief you the assignment, yeah.